Okay, welcome back to COP1334 Introduction to C++ Programming. I'm Professor Lusby, and this is part two of the fraction calculator demonstration tutorial, whatever you want to call it. But basically what I wanted to show you in this video is how we can take the pseudocode. Now that we've generated the pseudocode, how can we take this pseudocode and really what's the implementation? How do we put it in action using C++? Now, I will say that the beautiful thing about pseudocode is that we can take this pseudocode, if we do our pseudocode right, and we can apply this to any programming language out there. It doesn't have to be C++, right? Excuse me. This is half of the beauty of pseudocode, of representing code with UML diagrams, is that you can worry about the language specific details after you've come up with the actual design. So that's half the reason why we use pseudocode, is we're not driving which language is used. Now, are there some details with each language that may change the implementation and may change the way you write the pseudocode? Sure, but you know, from a high level, pseudocode is always a good thing to do first. So anyways, that aside, let's talk about, let's just kind of refresh our brain here a little bit. We created this main module for this fraction calculator, and we saw that there's a few main modules, a few modules that we're going to call. The first one is this menu module that's basically going to obtain our input from the user, right, and allow the user to select which one of these operations they want to do. That came from the requirements. The requirements basically asked us to do this. And then we found out that we're going to probably need another module that is going to allow us to actually obtain the fractional values that we want to use, the actual numerator and denominator. And notice that each time we come up with a new module, right? Each time we come up with a new module in pseudocode, we're constantly thinking about input, process, output, input, process, output. The reason being, and we're going to see this in the third video when we create unit tests, if you abstract the input and the output, it's going to make for very testable functions. Okay, so we constantly want to ask ourselves, what is the input we need, you know, from other functions from the outside world? That's the input here. What's the output needed that other functions need to know about, that the outside world needs to know about? So we really need to get into this IPO process anytime we define a module. So we've got the menu module. We're calling the input fractional values from user module. And then we get to the main process of the main module, right, where we look to see what the user selected. If it was add fractions, obviously we're going to call the add fractions module. If it was a subtract fractions, right, we're going to call the subtract fractions module. And if it's multiply fractions, multiply module, etc. So please, if none of this sounds familiar, watch part one, and I go into very lengthy detail as far as how I came up with this pseudocode. So now the question is, what is the next step? The next step is to basically go to take the pseudocode, and I've actually implemented the code already, just because I didn't want you guys waiting on me typing this in. And remember, we took all of these modules that we found out we needed in the main module, and we basically copied and pasted them down below, and then we created the actual pseudocode inside of each one of these modules that we came up with in the main module. So for instance, the menu module, we saw that we needed to do these certain things in order to make it work. The add fractions, we copied and pasted it down here. The input, process, output, add fractions. Notice that none of these things are defined yet. We just declared them all as void functions, and that's just kind of as a placeholder right now, right? I didn't want us worrying about the return type or the actual parameters for all of these functions just yet. I just wanted to make sure that we had placeholders in place. We had our pseudocode and our comments in place so that when we go to implement all of this stuff, everything's basically laid out for us, and all we have to do is type in the implementation. Okay, so we basically took everything that was up above in the main module, copied that above each one of the functions, and then we talked about how do we actually implement this functionality inside of each one of these functions, and all of that is pseudocode, right? And all of that takes time. This isn't just going to come off the top of your head. You really need to think about the input, process, and output for each one of these. You really need to think about the pseudocode implementation of each one of these modules. Now, once we have that, okay, notice I've got the same thing here, right? We've got our we're calling out what the module is. We're calling out what the description of this module should do, and then we're calling out what's the particular input, process, and output. And I'm going to show you how to use all of this pseudocode. All right. The next thing we saw was this was our pseudocode. Everything in green was basically our pseudocode from our design. And so what I've done is I've gone in and actually added the equivalent C++ statements here that it will allow us to do this. Now, you're going to see that in the pseudocode when we talked about the menu function here, we didn't have a loop here. Okay, and I'm going to explain here in a second why all of a sudden we have a loop. Okay, so let's ignore this part for just a second. All right, but long story short is, in the pseudocode it says we want to display the menu to the user. So that's basically exactly what I did. Was I included a bunch of cout statements to display the menu to the user. The next thing we said in pseudocode was that we wanted to basically tell them to make a selection. So fair enough, we do a nice little cout statement that lets them know that we need to make a selection, right? And then we come to this line, input menu selection from user. Well, how do we get the actual menu selection from the user? We use a cin statement. Fair enough. So we go ahead and we input the menu item selection. And the next pseudocode statement is validate menu selection. And this is what a lot of new programmers forget to do, right? They assume that the user is going to put in valid input, and you never really want to assume that. Okay, there's a lot of people that could take advantage of that to crash the system, cause havoc, and so we always want to do validation on any kind of our input. So what we want to check for is that our menu item selection is basically between 1 to 5, right? 1 being add fractions, 2, etc. We want to make sure that it's a valid selection between 1 to 5. Now, what I did was I actually created a enumeration type called menu, and if we scroll up to the type, so at this point I want you guys to realize that you're not always going to know everything up front. Your pseudocode is not going to tell you that you may need an enumeration here, but at the same time I don't want to hard code these values in as 0 and 6, because that's what's called magic numbers, right? We don't ever want just magic numbers in our code. Nobody's really going to realize what in the heck is this 0 and 6. So what I've done is, let me put these guys back. Okay, what I've done is I went up to the top and I've declared a new enumeration type that gives very descriptive names to each one of these, right? Menu add is basically equivalent to number 1. Right, the number 1 item in our menu. Menu subtract is equivalent to the number 2 item. So I've given them some nice names using what's called an enumeration type, okay, the details of which are in your book, and it's just an easy way to give very descriptive names to each one of these numbers, so that we're not using these magic numbers. Right, magic numbers are never good. All right, so once we do some validation on the menu selection, again we're back here in the menu function. We want to check to see if it's an invalid entry, if it's not 1 through 5. We basically want to prompt the user and say, hey, look, you have a completely invalid menu selection. I need you to try again, right? Please put in a valid menu selection. And what we're going to see is the whole reason I added this loop is that I wanted an easy way to come back up here, display the menu again, and tell them to make a selection. Okay, so the whole reason I created this while loop here is so that we keep looping, right, until the menu item selection is an actual valid value, right, between 1 through 5. Okay, so this whole do while thing, I didn't, I didn't discover that until actually writing the code and realizing, hey, we really need to loop. We need to loop this entire process until the menu selection is valid. Notice that, that didn't occur to me when we were first writing the pseudocode for menu. So code is, what I want to get at is code is constantly changing. Don't don't ever think that you're going to know all the details of all the pseudocode, of all the code up front. Okay, software engineering, designing software is an iterative process. Okay, your design, you give it your best shot up front, and then you basically modify it iteratively as you come up with your needs. But don't try to write code without doing design first, because then you're going to end up with some very um, uh, complex software that's hard to test as well. So there's a happy medium with coming up with a good design. Maybe you don't have all the implementation details and you just have to define a few new ones like this do while loop. That's okay. Okay, so please keep in mind that you may want to modify your pseudocode a little bit as you go on. That's why I added this do while loop in our nice little menu function here. All right. With that said, once we're done, once we actually have a valid menu item selection, it's going to jump outside of this while loop, and we're going to return. We're going to actually return the menu item select. So we're going to return that to the outside world. The whole point of this function, right? In case we ever lose sight, what in the heck are we supposed to be doing with this function? That's the beauty of this up here. Right? That's the beauty of the code that we put inside the main function. What is the input? The input is there's none needed from the outside world. The whole point of this menu module is to display a menu and then return what the user selected. Okay, so again, that's the whole reason we're defining the input process output up front. The output is once the user has selected this menu item, we're going to return that to the outside world, or the other functions. The other functions need to know what it is that we selected, right? So that being the case, that's why we're using this return statement. And remember that when we use a return statement, that is this value here that precedes the function name. Okay, we're basically saying, hey, this is the return type. We're going to return an int. Which is the actual particular menu item that was selected. So anytime we use a return statement, right? Anytime we use a return statement, we need to make sure that we change our return type. So notice in the pseudocode, we just use these placeholders. We declared all these functions as void functions with no parameters. Now we're starting to need to change and figure out, okay, we do have a return type here, right? We are returning the menu item select. We need to change that void to an integer. Okay, do we need any parameters from the outside world? And the answer is no. We need no parameters from the outside world because we're allowing, we're getting the input directly from the user. Now there's some implications to this as far as the testability of this function. I'm going to talk about that. Later. All right, so enough about the menu function. Okay, we basically modified the menu function to return an int, and we gave it a nice big do while loop that displays the menu and keeps asking for valid menu selection, and then we finally return it. Let's go to the next function. And again, if I ever go too fast, please feel free to pause it, really look at the code, look at the pseudocode, and see if it makes sense. Okay, really try to absorb the pseudocode and the implementation before you continue on to the next module. So now the add fraction module. Again, we took the pseudocode that we created from the from part 1, right? We came up with, okay, we need an add fraction module that takes this as input. It does this to it, right? The process, we add all the fractional values, and in its output, we want to return the resultant numerator and denominator. That's kind of the whole point of this module, is to take the fractional values, perform the operations, perform the process, and then output. So then we looked at the actual add fractions module and said, okay, what's involved in order to accomplish this particular process, add the fractional values? And again, we always want to look at input, process, output. Okay, so for input, if we look up here, for input, we don't really need to declare any variables because we're going to see that all of our input is coming from these parameters right here. Now you're going to say, where the heck do these parameters come from, right? You come down here, you look at add fractions. In our pseudocode, there's no parameters. It's just a void placeholder. Well, that's just it, right? When we look at this, now we're worried about implementation, right? And we can see that for input, we need these four values, right? The numerator and the denominator for the first fraction, the numerator and the denominator for the second fraction. So guess what? You do need to add parameters. That's when now we need to start adding parameters to our modules to meet what our pseudocode says. Okay, so I went in and said, you know what? We do have these 4 pieces of information that we need as input. Typically with fractions, they're whole numbers on top and the bottom right. They represent a fractional value, right? So you're not going to see let's say a float on top of a fraction and a float on the bottom of a fraction. They're always going to be integers, maybe even yeah, they're basically always going to be integers. So that's why we declared them all as ints. And we're going to talk about where did these other 2 parameters come from here in a second. Okay, but right now we saw as input we needed these fractional values, so we included those as parameters. So for input we have these parameters declared, we're good. For the process, at first it would seem like we need these new result, let's say these new result numerator variables declared inside the function, right? Let's just say we declare these inside the function. It's probably going to complain because there's 2 of them, but maybe not. We'll find out here. Okay, and we want to add, in order to add fractions together, the resultant numerator, we're basically cross multiplying the second denominator with the first numerator. This is just from rules of mathematics, right? If we want to add 1 half plus 1/4, we need to find the common denominator and scale up each one of these numerators to meet the new common denominator. That's where I got this formula from. Okay, and this is just from your mathematics knowledge, right? If you don't know that, then yeah, you might need to do a little bit of research to find out, you know, if we're adding 2 fractions, how do I find out what the resultant numerator is? That's not what I'm teaching, right? That's assumed that you have that knowledge from your prior math class. If not, that's also what this tutorial video is here to show you, is how you would take the numerators and denominators in order to get the resultant numerator. For the resultant denominator, it's basically just multiplying the 2 denominators together. But the short version is that we're creating a new resultant numerator, we're creating a new resultant denominator, and we're going to see in a second that if we keep these as local, we're kind of shooting ourselves in the foot, and I'll explain why. So this is the process. This is the process that will get us the answer for the resultant numerator and the resultant denominator. Okay, so the process part of this function is complete. But now if we look at the output, return the results. Okay, the output is return the results. What are the results? Well, the results are the actual result numerator and the resultant denominator. If that's truly the case, and we keep these guys as local, the outside world's not going to know about this stuff. Okay, so, and there's another problem. We have 2 values that we want to return here, right? Because we have 2 values that we want to return, we can't really use our return type because our return type can only return one thing. Now, when you get into more advanced C++ topics, you're going to see that there's something called a structure that we could use, and we could just return one structure with all this information. But if you don't use structures, there's a second way we can do this, and that's basically adding parameters. Okay, that's why I've added these 2 resultant numerator and resultant denominator. And if we want to use parameters as output, which there's some debate whether or not that's a good thing or a bad thing, but in this case, because we want to return 2 values and we don't know about structures, we're going to return these parameters using what's called pass by reference. These little and symbols here allow you to allow you to basically manipulate, change the result numerator, change the result denominator, and when this function returns, okay, the original function that called it, you're going to see these results, is the short version. So anytime you want to use parameters as output, you're going to use pass by reference. So that's why I added these other two parameters here, right? Is that we needed for output, we want to return the results. We don't know about structures, so we can't use the return type. Return type only returns one value. So I added these two parameters. I passed them by value so that we can return two things. Okay? So that being the case, I can now get rid of these local variables that I called and just use these parameters to store the results. Okay? So these four parameters are basically used for input. These two parameters here are basically used for output, and that being the case, we don't need to change the return type. Okay, we're returning our results through these parameters here, so we don't need to return anything. We can leave this as void. And again, this is just one way to do it. The preferable way is using structures and returning a structure, but we don't really know about that just yet. Okay, so for right now, we'll just return the result using these two parameters. Okay, so again, if always pause this video. Anytime that something needs to sink in, pause this video and really look at this code here and make sure that you understand where the input's coming from, what the process is, why is this process working, and then where is the actual output results, right? And we'll see that this is the input, right? This is the output, and this is the actual process. All right, so that's for the add fractions. Once you understand this one, I think you're going to see that the next three functions are very similar. Okay, so let's move on to the subtract functions. Excuse me, subtract fractions. And you're going to see that subtract fractions very similar. The input is the first two numerators and the first two denominators. So I added these four parameters to represent the input. For output, we see that we need a couple of parameters to return the output, right? So I added two more parameters for the output, and then I basically just defined the process of how we subtract fractions. Okay, so for input, notice I'm always clarifying. For input, I'm using parameters. For output, I'm using parameters. For the process, this is the actual process. And the nice thing about this is, I know at first it seems like, wow, he's just really making things complicated. Why is he doing all this? This is going to make things very unit testable. Okay, and we're going to see that in part 3. Anytime you see input use parameters, anytime you see output using parameters or using a return type, now it's a testable function. Okay, if we had actually obtained input directly with a cin statement, or we did output with the cout statement inside this function here, you're going to see that unit testability is out the window. Okay, so we always want to break things up into modules, and if we can, always use parameters for input, always use parameters for output, and now your unit tests are going to be 10 times easier. Okay, anytime you put cin or cout statements inside your actual functions, you're going to run into testability issues without using stubs or mock frameworks, and that's a whole other class altogether. So we're not going to go there just yet. Okay, so please, again, if you don't really understand what's going on, pause the video for a second. Really take time to try to make sense out of this. For input, we're using these 4 parameters. For output, we're using these 2 parameters. For the process, that's what's going on inside of the function. Okay, multiply fractions. Again, same input, same output, right? The only thing that's different is the process. Notice that our resultant numerator and our resultant denominator, we calculate those a little bit differently. That's kind of the whole point of this function or module, is that we, in order to multiply fractions, we're doing things a little bit differently. to the numerator and denominator. For multiplying fractions, it's real easy. You just multiply straight across. Take the two numerators, multiply them together. Take the two denominators, multiply them together. Okay, so again, pause this video if you need to examine this multiply fractions function a little bit closer. And for the divide fractions, same thing. Input, we've got these four parameters, right? We always need this as input. For output, we need these two parameters. And the process is a little bit different for dividing fractions, right? We have to do something called inversion, right? We flip the fraction. We flip that second fraction. So that's why all of a sudden you're seeing num1 times denominator 2, because when we multiply fractions, that second denominator of that second fraction all of a sudden becomes the numerator. Okay, so notice that each one of these different modules, right, from add does things a little bit differently. That tells you it's a unique process, right? Subtract fractions does things a little bit differently. That tells you it's a unique process. Multiplying fractions, dividing fractions, each one does the math a little bit different, and that tells you it's a unique process that needs its own function. And also, the good thing about all four of these functions, they all, for input and output, they all use parameters. So all four of these functions are very unit testable, and we'll go over that in part 3. Okay, so those are the four main functions that your requirements wanted, as well as that main menu function that your requirements wanted. Now, last but not least, we've got a couple of new functions that I threw in there. And it's just to kind of help with the readability of code. One is called output results. Okay, if you look back at our pseudocode in the main module, you'll see that we have an output results. And if we want to output the results, right, and the whole point of outputting the results is we want to show these fractional calculations, we want to show them in equation form, right? So if we have 1/2 plus 1/4 is equal to whatever the answer to that is, we need to pass in for input. Look at everything that's needed for input, right? We need to know what's the numerators of the two fractions, what's the denominator of those two fractions, what's the resultant numerator, what's the resultant denominator. You need to know all of these things, including the operation, before you can represent this information in equation form. Okay, so knowing this, knowing that we need all of these things from the outside world, I've added all of these things as parameters to this function, right? That's the whole point of parameters. It allows us to take things input. It allows us to create input to the function. It allows us to generate output if we don't want to use the single return type. Okay, so I basically added for input, right? I basically added for input all of these parameters because we said for input we need all of these different things. Now for process, we basically want to display the fractional values in equation form. All right, easy enough. Now here's the weird part. In order to show, not weird part, here's the interesting part. In order to show the calculations in equation form, we need to know what operation was being performed. So we need to take the operation as one of our input parameters, and whether or not you guys use an if statement or a switch statement, right? There's always 10 different ways to do this. It's completely up to you, but I've found that beginning programmers understand if statements a little bit more. So in this case, I basically added an if statement for each one of these particular operations that we could have done. And you'll see that if the operation was add, then guess what? We're including the add sign in the middle of our string. If the was subtract, we're including the subtract sign in the middle of the string, etc. Multiply, we've included the star or the multiply, and divide, we've included our slash or division sign. Notice this division sign is the same as the the fractional line that we use, but you get the point, right? Menu add maps to this add, menu subtract add maps to the subtract. Is there a more efficient way to do this? Yes, there's always 10 different ways. I just wanted to create an example that was hopefully very clear to new programmers. There's definitely a much more efficient way of writing this, right? As soon as you see code that looks like it's copied and pasted, okay, as soon as you see this, you're going to see that there's always a simpler way to do this. So there is a more efficient way to do this. I just don't want to go into that just yet. And also a switch statement here, right? A switch statement here might have been much more preferable. A lot of people think that switch statements are much more readable than all of these if statements. They're also much more efficient, right? Because if you select menu divide, the computer is going to have to execute each one of these ifs to do nothing, and then finally this fourth if is going to produce the result. So that's all another topic altogether. Efficiency is another topic altogether. So for the output results, I just wanted to really clarify that we have to use this operation that was passed in as a parameter to figure out which one of these equations do we want to display. If you don't pass in this operation, then we're not going to know how to display our equations. Okay, so again, for output results, if you need to pause the video and really examine this code, please feel free. Notice that the output says none. Why does the output say none? Well, because to the outside world, to the other functions of this program, they could care less about this equation that we've created and that we've sent out, right? They could absolutely care less about this equation. The only person, or the only thing that cares about this equation is the user on the other side of this program, right? So whenever we're talking about input, process, output, these are things that other functions need, right? What is the input from the outside world? What is the output to the outside world or to the other functions? Okay, a lot of students get confused with input, process, output, and they think about their input to the keyboard, or they think about their output to the display. And it's not, when we say input, process, output here, and we're talking about functions, we're talking about to other functions. What's the input from other functions? What's the output to other functions? Okay, and if the actual displaying the results to the user, that's part of the process. That's not part of input or output. Okay, obtaining values from the user, that's part of the process. That's not part of the input or the output to the other functions. So maybe that's the big disconnect for a lot of new programmers, is when we talk input, process, output, the input and output is to and from other functions, not to and from the user. Okay, so please keep that in mind. And then finally, we have this last fraction called input fraction values from user. Here's an excellent example, right? For the input, there's none. What are you talking about? This function is called input value fractional values from user. Well, this input fractional values from user, the input is coming directly from the user, not other functions, right? So that being the case, there is no input needed from other functions. The process is to actually grab all of those values from the user. That's the process. It's not input or output. That's the process. And then finally, the output is, yeah, all of these values that we just received from the user, we want to output those so that other functions can use them, right? That's the output to the outside world, the output to the other functions. So for input, do we need to add parameters? No. Okay, so there were no parameters added for output. Or excuse me, there were no parameters added for input. For output, do we need to output values? You betcha. That's the numerator, the two numerators we grabbed, the two denominators we grabbed. That's why we included these four parameters. These four parameters here are for output, basically output only. Okay, so that's why those four parameters were added. The return type, we didn't need to change that because we're using parameters for output instead of the return type. Okay, so yeah, again, please examine this code and see if everything starts to sink in. So with that said, that's the first thing. Once you generate your pseudocode, really go in and create the implementation for each one of these individual modules. Don't look at the main module just yet. Okay, really create the implementation for each one of your modules that was called out in the main module. That's the first step. The second step is, okay, now let's look at the main module. Okay, now let's look at the main module and see how can we implement the pseudocode in the main module. Because now all of a sudden you're going to see that the main module is going to use all of these other helper functions, or all these other functions that we just created, right? And so if we look at the pseudocode, and we'll talk about this, we've got another loop here. Again, this loop didn't really occur to me or appear until after I implemented the code. So we'll talk about this loop here when I'm done. And again, these variables here, okay, you're going to create these variables as you need them. Okay, so as you're implementing the code, the pseudocode, you're going to see that you need certain variables. So we'll talk about that more in a second. So let's just look at the main module's input here. The main module's input. Call the menu module, and we want to store the actual menu output. Okay, how do we call the menu module? Guess what? It's basically just the name of the module with any parameters that are needed. If we go down to the menu module, you're going to see that no parameters are needed for the menu module, so you basically just include the open, close parentheses in a semicolon. Okay, so because no parameters are needed, we just do the open, close, semicolon. If we look at, and you'll see if you hover over it, if you look at the signature, it's saying that the return type is int. Okay, what that's letting us know is that once this function is done executing, it's actually going to return an integer. And now I know a lot of you are asking, well, what in the heck is that integer? That's this output right here, the menu item that was selected by the user. Okay, that's kind of the beauty of having this input, process, output pseudocode, is now all of a sudden, oh, menu is going to return the actual number of the menu item selected by user. Okay, we can use this if we store it off. We have to store off what that particular menu item is. And in order to do that, we needed to create a new variable called, and you can call it whatever you want. You can call it menu select, you can call it item selected, but the key is you need to come up here and basically declare it, right? At this point you realize, okay, I need to store the menu output. I need to declare a new int called whatever you want to call it, menu select in this case, that's basically going to remember what my menu selection is, right? I need to come up here to the top of main, declare this new variable. I've already done it here, but you know, that's the first thing is I'm going to call this menu guy. I want to store off what is returned, so I need to create this new int menu select variable that's going to do that. So my process was I basically typed in this menu guy, realizes that I needed to store it off, which is why I'm big on putting this in the pseudocode, and I created another variable in main, or the first variable in main, to store off which menu item was actually selected. All right, next in the pseudocode, we want to basically obtain the fractional values from the user, right? So now that we know what operation the user wants to perform, addition, subtraction, multiply, division, all of that kind of good stuff, we need to obtain the numerators, right? The numerators and denominators from these different fractions that we're going to use. So we want to call the input fraction values from user. So we go ahead and we type it in, input fraction values from user. That's one of those functions that we created down below. And after you type it in, you're going to see that there's 4 parameters needed for this function. Num1, numerator 2, denominator 1, denominator 2. We need to give this function 4 variables, and because you see the AND statement in front of each one of these variables, you realize that those variables are going to be used as output. Okay, so at this point you type in input fraction values from user, you realize that you need to pass 4 variables. That should be your clue to come up here and create 4 new variables that are going to store these values from the user, right? At this point you realize, hey, this function needs 4 values. I don't have 4 variables that I can pass to it. I need to create these 4 variables. Okay, And so that would be your key to come up here and add these four, numerator 1, numerator 2, denominator 1, right? These four variables up at the top of main. Okay, so notice it's an iterative process. We call the function, we realize what we need, we declare what we need at the top, and then we use it, right? Function, declare what we need, use it with the function. Okay, now we get down to the pseudocode part, and notice that all of the pseudocode was already pre-designed, right? That's what we did in the last part. So now if we look at the process, we see that we want to look at the menu selection, right? Where's this menu selection coming from? This guy right here, right? That's what the menu function did for us. It found out which menu item the user actually wanted to use, and we're going to look for the menu add operation. If we see the menu add operation, guess what? We're going to call the add fractions module, right? Because we already specified this in the pseudocode. Call the add fractions module. You're going to see that the add fractions module takes 6 parameters, right? The 2 numerators, the 2 denominators, a resultant numerator, and a resultant denominator. At this point, we should say, okay, do we have the 2 numerators? Do we have the 2 denominators? And the answer is yes. That is exactly what this function did for us. Is it went out, it asked the user for the 2 numerators, it asked the user for the 2 denominators, and we can use that information to help this function out. Okay, so we do have these 4 variables already declared, already used. The other 2 that are needed, the resultant numerator and resultant denominator, you have to ask yourself, have we declared those variables yet? Has another function used or created those variables yet? And the answer is no. We don't have a resultant numerator or resultant denominator. We haven't declared that yet. So we're going to have to come back up here to the top, and we're going to have to add a resultant numerator and a resultant denominator, come down here, and use them. Okay? And this is where the actual result of add fractions is going to be placed, is inside the resultant numerator and the resultant denominator. Okay, so again, we basically call out the module that we want to use. We see the parameters that need to be used, right? We figure out where those parameters coming from, and they're coming from either already existing variables or we declare new variables. Okay, and once you've done that, the output is it's basically stored in the resultant numerator, in the resultant denominator for you at that point. Okay, so at this point, add fractions is done. The output to add fractions, right, the results is stored in result numerator. It's stored in result denominator. We basically added our fractions. We've store the results of the operation. That's exactly what this is doing for us already. The function is literally storing the results inside of result numerator, inside of result denominator. We don't have to worry about storing off the results of the operation because that's done for us there. If you look at the subtract, okay, same things going on here. We're calling the subtract function, subtract fractions. We need those same 6 parameters, so we're going to pass in those same 6 parameters, and again, the results of subtract fractions are going to be stored inside of the result numerator and the result denominator for us. Okay, so we don't really need to manually do another operation to store the results of this operation. Same thing for multiply. Okay, again, if I'm going a little fast, please pause in between each one of these things. For multiply fractions, takes the same 6 parameters, and we're going to store our results inside result numerator, result denominator. For the division, same thing. Okay, so no matter what operation we apply, the answers are always stored in resultant numerator and resultant denominator. So once we're done, okay, once we're done calling the right function for the appropriate operation that the user has selected, now all of a sudden, guess what? Let's output the results. And in order to output the results, we're going to see that not only do we need 6 parameters, we need a 7th parameter that actually defines which one of these menu items we selected, which one of these operations that we used. And we saw why in the first half of this video, right? I went over why output results needs all 7 of these parameters. But at this point, it's basically you type in output results, you see oh wow, I need 7 parameters. Where am I going to get those 7 parameters? The first 4 are easy, right? Numerator, denominator. The next 2, oh hey, I've got the next 2 from the previous function calls. This menu select, do I have that? Yeah, absolutely. This menu select guy comes from this guy up here. Okay, so anytime we're calling functions, we're implementing these functions. Once you have them implemented down below, it's real easy to have. Or it's not easy. You basically call out the function you want to use, look at the list of parameters needed, and find these parameters. Okay, find these parameters and basically list the parameters that represent each one of those values needed for that particular function. Now, if I were to leave that program as is, I would be able to select one menu operation and do, one mathematical operation on a couple of fractions, and the program would end. That's kind of a worthless menu-driven program, right? We want the ability to do these things multiple times, right? To select add fractions, multiply fractions multiple times until we finally select quit. So that's why I took all of this code and created a new while loop. I basically want to keep looping over all of this code until the menu or menu item select is basically quit. Okay, so that's why I introduced after the pseudocode the statement here that we want to loop until the menu selection is quit. Okay, so with all of that said, okay, I think I went a little fast over the second half there. If we run the program, we should see that it works. And I'm just going to do an operation for each one of these real quick just to prove that it works. For instance, please make a selection. We select 1, add fractions. Oh, I don't know. Let's add 1/2 plus 1/4. We should get 3/4. But notice that it says 6/8. 6/8 is the same thing as 3/4. Okay, it's just not the simplest form, right? There's ways to reduce that. In the requirements, it said do not worry about reducing the final result. So we're going to keep our life easy and just show it as 6/8. So 6/8 is correct. If we want to subtract fractions, maybe we want to take 1/2 minus 1/4. We should see that that is equal to 1/4. And we see that it's equal to 2/8. 2/8 is equal to 1/4. We know our subtract's working. Multiply. Let's try 1/3 times 1/3. We should get 1/9. And we do. And let's finally try divide 1/2. Whoops, excuse me. 1/2 by I don't know, 1/4. And that's right. You should get 2. 4 divided by 2 is 2. Okay, and then finally quit. Now, I did this on purpose. Look what happens when I select quit. It's asking me for the numerator and denominators of these fractions before it quits. Okay, this is something that until you run the program, until you test the program, you're not really going to see it. You're not really going to see it unless you're really good. You're not going to think of that ahead of time, and the whole reason is that this while condition, this while menu select is not equal to menu quit, does not occur until after, right? Until after all of this code. So we're still going to perform all of this code here, and that's not good. So what we want to do is underneath this menu selection is say, you know what? If menu select is equal to, let's say, menu quit. Okay, if it's equal to menu quit, then you know what? Let's just continue down to the. Now, question is, let's just break out of this loop here. Okay, if menu is equal to quit, so we should probably put some pseudocode here and say, check to see if the user wants to quit. And in theory, this should fix our issue. And let's find out. Alright, number 5, quit. Woohoo! Alright, so this little statement here isn't, this is where software is an iterative development process. You're not going to realize that you need this statement probably until you run the program and you see what happens. Okay, so we basically just went back in, added a simple couple lines, and that'll actually jump out if the user selects quit in the menu. Other than that, I guess I was wanting to talk a little bit about efficiency. You can see that if we wanted to make this more efficient, right? There's always 10 ways to do the same thing. A couple of things. In the main function here, we've got all of these if statements, right? All of these if statements that are selecting on a simple equality operation. If menu selects add, if it's subtract, if it's multiply. When you see that, you should switch. You should rewrite this to use switch statements. A switch statement is much more efficient. It's not going to execute each one of these if statements. If let's say you select menu divide, you're gonna be executing each one of these if statements and taking up CPU cycles unnecessarily. So for efficiency's sake, I would say change all of these if statements in main to a switch would be one of the things that I would do. Also, let's see, efficiency of the menu. Yeah, this guy looks okay. Add fraction, subtract fraction, multiply, divide. I don't really see any efficiency. I would say that the resultant numerator and the resultant denominator should probably be put into a structure that is returned as a return type instead of using pass by reference parameters, because that can get you into trouble. But yeah, I would probably put these guys into a structure and pass back the actual structure instead of passing by reference here. For all of these, for add, subtract, multiply, and divide. Now, for output results, it occurred to me while I was creating this video that for output results, for input, from a testability standpoint, use parameters. That's great. Okay, so we can actually pass in all of the input to this function using the parameters. However, the output, all these cout statements, is killing the testability, the unit testability of this program. Not only is this redundant code that could be simplified, not only do we have a lot of ifs that could use a switch statement, there's no output. If we look down here at output, there's no output. So there's nothing that we can test without the user staring at the screen to see what cout does. So I would, if I was worried about testability, which you should always be, I would basically create strings, create a string parameter or a string return type that actually stores your actual equation in the string, so that when this function returns, you can look at the contents of that string and see if that is correct. That would make this output results function much more testable. Instead of using these cout statements here, assign the equation to strings, and that's going to make your life 10 times easier when it comes to unit testing. And then all of a sudden, this function is unit testable, right? Functions are only unit testable if you have input as parameters and you have output as parameters or return value. Anytime you have none here or none here, typically that means your function is going to be pretty difficult to unit test. You're going to have to manually test that function, and that's what we're trying to prevent with unit testing. We don't want manual tests. Manual tests take forever. People skip steps, and that's why we want to automate the unit test as much as possible. That's why we want to always have input as parameters and output as parameters to as many functions as possible. Now, for this input fractional values from user, input none. Yeah, the reason being that we're grabbing the input directly from the user. We can't really pass in input from the user, right? So because the whole point of this function, input fractional values from user, is to grab the fractional values from the user using cin statements. There's no real way to automate the unit testing of this function without manually having the user type in these values so that we can use these CN statements. So this function here is a little problematic to unit test without manually running it. There are ways using stub functions and mock functions and things like that, but that gets into some complex territory. But I will say that if you research mock functions, you will be able to mock out possibly these CN functions so that you can have the test function relay these values. So from an efficiency standpoint, this is fine, but from a testability standpoint, this input fractional values from user, more than likely you're going to have to come up with some sort of mock test framework in order to automate the testing of this function. All right, so I think that's about everything that I wanted to cover. I hope you found this informative and useful. Please let me know if you have any questions, and hopefully I will put out the third video of how to create unit tests for all the unit testable functions here to kind of hopefully a lot of the unit testing things will start hitting home once you see an example of how we can automate the testing of all this code, so we're not physically typing in all this nonsense to test it. So thank you very much, and I look forward to our next lecture.